All right, so sorry, just take my keyboard off. This video is going to go over all of the Unit 6 questions that are on the semester review, which is going to be from number 14. I wrote down number 8 for some reason, but number 14 to 36. So starting off, writing the trig ratio as a simplified fraction and as a decimal. It's really straightforward. Since we want sine of A for 14, we're going to look at angle A. Sine, remember, so katoa, that is on your reference sheet, but sine is opposite over hypotenuse. So from A, 7 is my opposite because it's across the triangle, and hypotenuse is AB, so that would be 25. So my fraction is 7 over 25. And then as a decimal, 7 divided by 25 is 0.28, so 0.28. And there's no rounding needed for that one. For cosine of B, now we're looking at angle B. I would have 24 as my opposite, 7 is my adjacent, and the hypotenuse is still the hypotenuse. That doesn't change. But if I want cosine, it's going to be adjacent over hypotenuse. So adjacent is 7 and hypotenuse is 25. So notice it's exactly the same as number 14. So it's going to be 0.28. And then if I want tangent of B, tangent is opposite over adjacent. So that would be 24 over 7. And 24 divided by 7 is 3.43. Is 428 if you're curious, but that 8 tells us to round up to 4.3. So then, using a calculator to find the trig ratio, you just have to grab your calculator and type in sine of 64, and that gives you 0.898. So because we were rounding to the nearest hundredth, we look at that 9. That 8 tells us to go up, so 0.89 now becomes 0.90. For cosine of 58, it is 0.529. So again, looking at the 2, that 9 tells us to go up, so it's going to be 0.53. And then tangent of 15 is going to be 0.267. And so looking at the 6, 7 tells us to round up again, so it's going to be 0.27. All right. So for number 20, we want to find the missing lengths. So technically, once you know 2 of them, you can use Pythagorean Theorem. However, I would recommend just using Trig because then you don't have any rounding issues or anything like that. So starting with xy. Xy is this side, which is the hypotenuse. And so looking at this 41 degrees, that 12.2 is opposite. So opposite and hypotenuse is sine. And I'll write SOHCAHTOA again in case you need it. But it is sine. So we'd have sine of 41, because we know our degree measure, is our opposite side, which is 12.2, over the side we want, which is the hypotenuse, so we just say x. So then to solve this, we multiply both sides by x first. So we have x times sine 41, and if you want, you can have that little multiplication in there, 12.2. So then we divide by sine 41, boop, boop, and x equals 12.2 divided by sine 41, and hopefully you have a calculator that you can just type that straight into, but that gives you 18.595. So looking at that 9, the 5 tells us to round up, so we know xy is 18.60. Again, 59 would just round up to 60. So then for xz, we would have xz is our adjacent. So then because we have opposite and adjacent, that would be tangent. So then tangent of 41, again, we know that degree measure is opposite over adjacent. So notice it looks exactly the same setup. The steps are exactly the same. You multiply by x, but ultimately we get to this part where your x is equal to this divided by that stuff. Now, some people can see it and just do it automatically. Some people forget that it's only when the x is on the bottom. So make sure you understand the algebra behind it before you use shortcuts. So we'd have x times tangent 41 equals 12.2. And then divide by tangent 41. So then x equals 12.2 divided by tangent of 41, which is 14.03. And it's 0.34, so then we're just going to round and keep that 0.3 because we keep that 4 tells us to keep. So then for 21, we want to find HI, which if you notice, HI is this side right here, which is adjacent. And then the 100 is our hypotenuse. Remember, the hypotenuse is always opposite the 90. So adjacent and hypotenuse is cosine. So we're going to have cosine of the degree measure equals adjacent, which we don't know, over hypotenuse, which we do know. So this is where knowing the algebra helps, because some people will try and do that shortcut like we were able to do for number 20. But for this one, because the 100 is in the bottom, we are going to multiply by 100 to both sides. So now we have 100 times cosine 55 equals x. So then in your calculator, 100 times cosine 55 is 57.357. And technically it'd be 358 because it does round up. But because we need nearest hundredth, I only care about the first three. So looking at this 5, looking at that 7 tells us to round up. So we'd have 57.36. And this would be centimeters. And I realized I did not put units on any of these. Oopsie. So inches on number 20 and centimeters for number 21. So for 8.3, you have to use your inverse trig. So if you see a setup where sine of a letter equals a fraction, that tells you that you're using inverse trig. So this sine of a equals 8 over 17 becomes inverse sine of 8 over 17 equals a. And if you recall, inverse trig is always used to find your degree measurements. So inverse sine of 8 over 17 gives us 28.07. And so because we're going nearest degree, it's just going to be 28 degrees. Okay? So then for the next one, if we were to write it with inverse trig, we'd have inverse cosine of 13 over 17 equals a. Oop. So then putting it into the handy-dandy calculator, inverse cosine of 13 over 17 gives you 40.11. And again, nearest degree, that's just going to be 40 degrees. And then last but not least, it is inverse tangent of 15 over 8 equals a. So then, oopsie, equals, there we go. Inverse tangent of 15 divided by 8 is 61.92. So then going to the nearest degree, we look at that 9 and we know we need to go up, so it's 62 degrees. So make life simpler to see the answers. It's this, this, and this. All right. So solving special right triangles is going to use regular trig and inverse trig and potentially Pythagorean theorem. So looking at this one just right off the bat, I noticed that I know two sides. So because I know two sides, I can use Pythagorean theorem. So to find AB, I'm just going to plug it into Pythagorean. So that would be 4.2 squared plus 6.5 squared equals c squared, because c is opposite of the 90. So 4.2 squared is 17.64. 6.5 squared is 42.25. So then when we add those together, we get 59.89. And then square root of that. Oops. Push the wrong button. Square root of 59.89 is 7.738. So rounding to the nearest hundredth, because it is a length, we are going to have 7.74. Okay, and I'm actually going to just go ahead and box this with the highlighter now. So then measure of A. If we want to find the measure of angle A, we're going to be looking at A. And I always try and use measurements that I know for sure that they give me. So with that, if I'm looking at A, 6.5 is opposite and 4.2 is adjacent. So then I know that A is going to be opposite adjacent, that's tangent. So it is going to be inverse tangent because I'm looking for the angle of the ratio, which is 6.5 over 4.2. So look at how that's set up. It's the angle name equals your trig function that represents the sides, and then the ratio of the sides for that trig function. So inverse tangent of 6.5 divided by 4.2 gives us 57.13. So rounding to the nearest degree, because this is an angle, that would be 57 degrees. And some of you may opt to just subtract from 180 in order to get B, and that is fine. Others of you may choose to do other trig. And personally, I would just do more trig just to double check. I don't know why my pen's not. It is changing colors, but it's not changing colors. It's weird. But if we use trig for angle B, now my opposite is 4.2 and my adjacent is 6.5. So then we're still going to use tangent, so inverse tangent, except now it's just flipped the other way, 4.2 over 6.5. Oops. Bless me. And it would probably help if I used a B instead of an A because we were talking about angle B. My bad. But inverse tangent of 4.2 divided by 6.5 gives you 32.86. So again, rounding to the nearest degree, that 8 tells us to round up, so that's going to be 33 degrees. So then if you wanted to just double check your work, 180 minus 90 because it's a right triangle, minus 57 minus 33 should hopefully be 0, but we'll double check just to make sure. And it is, so we are good. So now we'll do basically the exact same thing. If you are given a case where you only know one side of the triangle, but you know an angle, then you would have to use regular trig in order to find it. So just FYI in case it pops up. So starting off, I have two sides, so I'm going to just go ahead and use Pythagorean Theorem. But I do notice that it's one of my legs I don't know now. So it's going to be 1.25 squared plus b squared equals 3 squared. So that's 9. And I do not know what 1.25 squared is, but my calculator does, and it's 1.5625. And personally, I know some of you are just always wanting to round as soon as possible. Try and avoid it if you can, because when we subtract, we get that b squared is 7.4375. So I subtracted the 1.5625. Okay, and so then when I take the square root, but because I did not round this 5625, now I know that I can round my b because that's my final answer. So 727. So rounding to the nearest hundredth, that 7 tells us to go up. So it's going to be 2.73. And this would be meters. And I realized again I did it. Bad me. That is inches. Okay. So then to find angle D and angle E, we're going to use inverse trig. So if we want to find angle D, it'd be right here. I have my adjacent and my hypotenuse. So because I have adjacent and hypotenuse, I know I can use cosine. But because I'm looking for the angle, I'm going to use inverse cosine. And then adjacent is 1.25, and then hypotenuse is 3. So then plugging it into the calculator, inverse cosine 1.25 divided by 3. Sorry, I mistyped again. And that gives us 65.375, blah, 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 blah. So because we're going nearest degree, that 3 in the tenths place tells us to just keep it. So D is 65 degrees. And then for E, this is the one that we were supposed to change. So technically E we know is 90 degrees, because it is, oh crap, I knew that was going to happen. Because E is the 90 degree, we already know that one. Technically, that's supposed to say angle F, but it doesn't. So angle E, for the sake of being correct, is 90 degrees, but the measure of angle F is what we really want to know. Oopsie. We're not perfect yet. Dang it. Ooh, what in the world? It didn't like that. So I'm adding this measure of angle F because that's really the one we want. So looking at angle F, that's right here. And F, we have opposite and hypotenuse now. So because it's opposite and hypotenuse, that would be sine. But we're going to use inverse sine because we want the degree. So then it is opposite 1.25 over 3. So you notice the ratio doesn't change, the trig function does. And that's totally fine. 1.25 divided by 3 is 24.6. So then that 6 tells us to round up, so angle F is 25 degrees. Or if you subtracted from 180, that is totally fine too. 180 minus the 90 degree angle we have, minus 65 gives us 25. So again, with that check, 180 minus all these degrees will give us 0. So we are good to go. Boop. All right. So the next part was I would say, easy part is angles of elevation and depression. Remember, when you're doing it, it's always based off of that horizontal line. So angle 1 from this horizontal line goes up, so it is an elevation. Angle 2 goes down, so it is an angle of depression. Angle 3 from its horizontal line goes down, so it's an angle of depression. And then angle 4 from its horizontal line goes up, so it is an angle of elevation. Okay. So for number 31, Lindsay shouts down to Pete from her 3rd story window. So I'm just going to go ahead. Boop, boop, boop. Lindsay's up here. Okay. That's Lindsay's head. And she is 9.2 meters up. And the angle of elevation from the ground to where Pete stands, so Pete, who's over here, boop, that angle of elevation from the ground, so right here, is 79 degrees. And we want to find the distance from Pete to the base of the building to the nearest 1/10 of a meter. So based on my picture, I know that Pete's down here, so I'm really looking for this distance right here, where it's from Pete to the building. So because of that, I know that 9.2 is opposite, of the 79, and that the side I want is my adjacent side. So opposite and adjacent is tangent. And because I have my degrees, I'm just going to use regular tangent. So tangent 79 equals opposite, which is 9.2, divided by adjacent, which is just x. So then to solve this, we would multiply by x to cancel it out on the left. So we have x times tangent 79 equals 9.2. And then we divide by tangent 79. Boop, boop. So then 9.2 divided by tangent 79 is 1.788. So because we need the nearest 10th, make sure you're always aware of what you're supposed to round to. 10th is the first one. So looking next to it, that 8 tells us to round up. So it's going to be 1.8 meters. Okay. All right. So then for number 32, we have an observer in a lighthouse that is 69 feet above the water. So this is my lighthouse. lighthouse, boop, boop. And we know it is 69 feet above the water. Now, we sight two boats directly in front of us, and the angle of elevation to the nearest boat is 48 degrees. Angle of depression. So because I know it's an angle of depression, I'm going to go ahead and draw this horizontal line in. And I know that I see two boats, so I'm going to go ahead and draw boat 1, boat 2, because it doesn't have to be proportional. If you want, you can be really fancy and draw some water in, but it doesn't matter. Just make it more entertaining. So we know angle of depression to the nearest boat. So from us to the nearest boat, that angle of depression is 48 degrees, which tells us that this angle down here, which I'm going to draw in a horizontal line, that way we have it, but this angle down here is going to also be 48 degrees because of alternate interior angles, because this is going to be parallel to this one down here. So then the distance, and I'm going to use a different color now, the angle of depression to the other boat is 22 degrees. So from there all the way to the other boat, this angle is only 22 degrees. So again, alternate interior, I know this angle is 22 degrees. So then we want to find the distance between the two boats. So that's going to be this distance right here. And we're going to round to the nearest hundredth. So again, if you keep note of it, there you go. So because we're looking for the distance between them, I'm going to say that x is the distance to the first boat, and that y is the distance to the second boat, because then if I have both of those distances, then I can just subtract them. So solving for x first, with this 48, 69 is opposite, and I also just noticed that with the 22, 69 is still the opposite because we're looking at the bigger triangle. And then my x would be my adjacent side, and just like the 69 is the opposite for both, the y is also adjacent. So setting this up, it's going to be tangent. So let's just do some different colors. So we would have tangent of 48 degrees. So we're doing the first boat first. Is going to be opposite. So 69 over adjacent, which we don't know. So we're just going to call it x. So we multiply both sides by x to cancel it out. Remember, don't use the shortcut unless you know the algebra. Okay, and so, there we go. So then we divide by tangent 48. So then x is 69 divided by tangent 48, 62.127. So again, they wanted nearest hundredth, so I'm just going to go out to the third. And then for the second boat, we are going to do, let's do green, which I don't know why the pens aren't changing color, but it's fine. But it's the exact same setup, except it's tangent of 22 now equals opposite over adjacent y. And this is why I like to use different letters, because then I'm not confused on which one is which. But we multiply by y. So y times tangent 22 equals 69. And then we divide by tangent 22. I know some of you are really tempted to just find what tangent 22 is and leave it as a decimal. Please avoid doing that, because then you run into more rounding issues. But 69 divided by tangent of 22 gives us 170.7809, and I'm only going out because it rounds funny. But now that I have the full length, now I can do y minus x, which is 170.7809 minus 62.127. So that minus 62.127 gives us 108.65. And it's 653, so it just rounds to 65. And that is in feet. Okay? So again, you're basically just finding tangent twice and then subtracting the difference. All right, there we go. All right, so then for 33 through 36, it is special right triangles, so you cannot be using a calculator. Now with these, I'm going to show you the shortcut way because I feel like the shortcut way is a bit easier for a lot of people. Now, if you are using the Trig way, by all means, continue doing that. Just double check your work with the answers we get here. So if we use the shortcut way, the rules, and you're given the rules on your formula sheet as well, is that your short legs with a 45 are x and x, and then your long leg or your hypotenuse is your x square root of 2. So because they use x to define your long leg, you may choose to switch the x to like a b or something. It doesn't really matter, but as long as you understand what that means. So because I already have this value for b right here, this 8 root 2, I can just plug it straight into that b. So again, this is the shortcut way, so you'd be showing your work exactly like I am, but you're going to plug in your b value, 8 root 2, and then you're going to multiply it by the square root of 2 because we're just doing our hypotenuse. So square root of 2 times square root of 2 is the square root of 4, and the square root of 4 is 2. So 8 times 2 is 16, and voila, you're done. This is why we like the shortcut way. Okay, now if you used trig, you probably would have used like sine, so you'd say sine 45 equals opposite 8 root 2 over hypotenuse, and then your sine 45, remember, is square root of 2 over 2, or if you came over here, you'd have 1 over root 2, both are the same, but if we use those ones, 1 over root 2, 8 root 2 over b, notice that when I cross multiply, I'm doing 8 root 2 times root 2, which is what I did right here. And then 1 times b is just going to be b. So you still get the same result if you do set it up with trig. So for 34, we're going to change the colors. This is a 30-60 triangle. So with these, because they use x and y again, I'm just going to use b because it's mildly easier. But my short leg is always what everything is based off of. So my short leg, let's say, is b. My hypotenuse is double that, so it'd be 2b. And then my long leg is the short leg times the square root of 3. Again, these rules are on your formula sheet. Look at them. Make sure you're familiar with them if you're going to use this method. So if I want to find x first, x is the long leg. So we're going to go ahead and do that.